got George Fereday, who's just told me that he moved to Kent and he started discovering chestnut. And they're going to talk about a project where they've been working with chestnut called Homegrown House. And maybe what I should say also about George is that he teaches at London Metropolitan University. And they've done 2 phases of this, and they've just told me they're just starting on their 3rd phase. And just kind of very quickly, if we could have 100 of these projects in the southeast, 100 homegrown houses blossom, that would be a fine thing in terms of timber transformation for the region. And so kind of, why not? That's an idea. Anyway, off we go. Welcome Nick back, and welcome George to Lewis for possibly the first time talking about one of these things. Thank you.
Well, thanks for having us, and pleasure to be here, and thank you for everyone's interest. So yeah, I'm George, this is Nick, and this is an image of my local woods up in Kent near Gravesend that Oliver mentioned. And I was just saying earlier to him that I suppose like all the best projects, this one started with a walking woods, and sort of a keen interest in this from just exploring my local environment really. So coming out of London, it was quite new for me to walk in a kind of coppice landscape, and I was sort of intrigued, and that was the start of it. And I met Nick, who was at the time working down at the Enterprise Centre in Sussex, and we sort of developed a project from quite humble beginnings on a simple kind of theme, and I'll show you some images of developments. I'm not sure I control this.
George, could you speak a little bit louder?
Yes, sorry. Yeah. So the Homegrown House project, just to introduce it quickly, it was some research that was funded by my university, London Met, and was in collaboration with Grown in Britain, Mule Studio, who are structural engineers, Burling Timber were the sort of venue for the project, and supplied the wood that we used. And Nick was one of the fabricators and designed the project as well. We worked fairly closely with Wood Miser too, who helped us with some of the processing. But just to kind of give you a bit of a backstory, a bit of an introduction, the Homegrown House project is just a label really for a package of sort of research that was looking at ways to kind of evolve sustainable architecture through locally sourced timber, and the intention was always to kind of invigorate a local kind of woodland economy through design with this, what we felt was quite underutilised material. So most of this coppice that I kind of pass through in Kent ends up in Sandwich Power Station, sort of biomass. And it always feels kind of a sort of travesty that we don't, use it for better things first and cascade it through a series of functions. So that was the kind of starting point. We also were developing engaged students as well on the sort of journey of discovery that we were going through, and we're also keen through encouraging woodland management through coppicing to sort of reinvigorate biodiversity in some of the local landscapes around sort of fringes of London that aren't currently managed at all, and prone to disease and things, these trees. So that's a kind of quick backstory. The images we'll show was from the latest phase of the project, which was to sort of put together a demonstrator kit of parts, all made from sweet chestnut, that was either small, medium or large diameter coppice thinnings, and to focus on design for different assemblies, trying to think about circular principles as well. To align with management practices in the region. So just to give a bit of kind of geographical context, this is the university, This is the Isle of Dogs where Nick and I did our first foray into chestnut beans and things. And then this is Badgerswood, which is where we sourced and built the structures that we'll show you. It's about an hour and a half's drive from the university, kind of going into the northeast of Kent. This is where we exhibited all of the pieces. What's quite nice in this image is you can see the kind of acre that was felled. This is the regrowth of chestnut from the year before. And I think this was about 30 years,
yeah,
something like that, behind. So you've kind of got this kind of layered landscape, which was great to exhibit the pieces in. Sorry, do chime in. I'm conscious I'm kind of spinning a little bit. This is the main image we wanted to show you, Nick and I, which was, if you like, the outcome of the project to date. So do you want to talk maybe a bit about the processing side?
Yeah, absolutely. So that view of the final crop, the mature coppice, is really what we wanted to go back to and just see what the bare resource was. Frighteningly cheap to buy an acre of sweet chestnut coppice, considering what's there. To go at is staggering that for a few £100 you can have an acre of it. There's still auctions that you can go and just bid and get. You have to buy more than an acre, but so it's really quite beguiling to see that resource and work from that stage. So often, as practitioners, we end up much further down the chain when somebody's already added 20 times the value to it and changed it and made decisions about it. So we had the luxury with the funding from London Met to go back into the woodlands, and it took a little toing and froing to get the confidence to, I think it's true to say, to get back to the very basics of splitting a pole into two pieces and just being happy with that. Just as a process, that's a pretty good thing to do. How much better it looks and feels to have, okay, we've got one straight face now. We've done very little to it. We haven't added a whole heap of money to it. And we've got something that looks aesthetically incredibly pleasing and it's usable to a degree. So I think the half round cleft was a great starting point. It was then quite sobering to say, well, we've cleft it, therefore it's not necessarily straight, it's followed the grain, literally. So it seemed logical to saw it into two pieces to see if that's an advantage. At least we then know that it's going to be straight and it's going to be in line with the both ends. So we've got a data point to work to. And then it starts getting really interesting and sobering that sawing a round bent pole into two clean pieces gives you less options, not more, than a piece of cleft wood. That you've then got to select out half or more that aren't straight enough. You've then got to come up with the technology to be able to cut straight line in a bent pole. Seems like a sawmill would be able to do that, but most of the sawmills that would deal with small diameter are long gone. Even new technology like a wood miser, a mobile sawmill with a narrow curved blade, you would think would be quite good. Try to cut chestnut poles efficiently with that, really difficult. So we immediately started exploring some great issues. What have we got? What do we want to do with it? So when we were going to saw it, we came up with the concept of following the outside of the timber. So instead of wanting to put a straight line in it by sawing it, we followed the outside and ended up with cutting two flats on a pole, but following the grain, if you like, following the outside face. That gave us some interesting properties. The timber, by following the grain, was a lot stronger. because there wasn't any grain to split, there wasn't any short grain. It had the outside of the tree, which the properties of how a tree stands up is fascinating technically as to how we use that fibre and which bit of the tree is strong. So by putting the two outside lips, as I called them, together, we were able to bend a web structure. As I say, met George when I was working at the Woodland Enterprise Centre, which had some lovely bent lats on the outside, held up with a glue lap. We immediately found that we had potential for a beam product with straight grain that could be steam bent into a beam product, a bent beam product, and a lattice element. So again, simple processes, try and follow through with how it could be applied architecturally.
So the other thing to mention with this image, just to explain what you're seeing, this column showing the different kind of cutting techniques, different diameters of rounded, so sort of small, medium and large diameters. So that was ranging up to about 300 mil holes. And then these are kind of some photos of the kind of outcomes, if you like, which were kind of fragments, one-to-one scale parts of structures. And then we also generated with the engineers some parametric models, which I'll show you some images of in a minute, to test these principles at a bigger scale. We essentially didn't have a big enough budget to see all of these ideas through to the kind of building scale, but we could make kind of small kits of parts for each, which is what you're seeing here. Just on the processing side, the other thing to mention is, right from the outset in our brief, we were trying to be really strict with ourselves at reducing waste at every opportunity. So Nick's talked about cleaving, which was, I guess, you could say it's pretty close to zero waste, depending how you look at it. These were sort of parallel cuts. This is two saw lines. And the space road pieces were two clefts on a small pile, so you're getting kind of quarters, which there's an example over there. And should we talk about the radial?
Yeah.
That's probably the crux.
So that's where we started working together with your students in the Isle of Dogs on a design and make project, and always wanted to try radial cutting. Exploring how to do it technically, but also what the properties are of those elements. And there's an example of a section of XR beam. The cross section is the same as the Extinction Rebellion logo. That's the only reason it's called an XR beam. It does explore that properties that is inherent within a piece of roundwood that we can draw out by going back to basics. So this has had the top and bottom bark taken off it, but in its simplest form, it just has the bark on it and is 8. That picture's interesting. Yeah, 8 segments held together with plywood waste. That is a part of another project, which is to reduce waste in CNC production with WikiHouse. Large skips full of large lumps of plywood, by using some clever software to draw in components, small components, that tiles with the rest of the production setup. We can reduce waste in CNC production, and these are examples of that, where we can make small components out of very expensive plywood that would normally be junk. And we've taken that to the next stage. We were measuring the deflection with that quite basically. A lot more work to be done on it. What we're able to do now that we're pretty quickly at full size prototyping, really fast tracking this straight from the woodland into a mobile sawmill out to something that we can jump on and test. We immediately start getting payoff of properties that we didn't know that were there. Some of them aesthetic, so the beam that's made of these random thickness holes just looks beautiful. And on a drawing board that wouldn't have come out, that we probably would have ended up with square bits of timber. The aesthetic of that really important. One of the things that come out of this is that used as a floor joist between stories, just looking up the road with 3- and 4-story buildings, the floor layer acoustics are becoming quite important. We've got a 2-part beam with isolated components that are at angles, and for anyone that studies acoustics, know that we just happen to be onto something because we've immediately gone to full-size production really quite quickly. So there's that sort of vindicated our approach to going really back to basics, back to primary processing in the woodland, using appropriate farm scale, I think we called it in the documents, technology. So not a large investment, really quite basic, and the skill level that's appropriate to the woodland rather than in a factory. The last method of sawing came out of, I think it was Meclam, wasn't it? It was suggested as a way of bending components with, by thinning them by sawing them quite thinly. And I think this was a good lesson for us in watching and listening to what the tree wants to do. We pretty quickly found when we tried to bend it together that the other things were quite willing to be manipulated in that way, but we physically weren't strong enough to hold a Meclam beam together.
Meclam is kind of shortened version of mechanical lamination. So yes, rather than glues, holding everything together with blocks.
And so we just found that by fanning them out and putting blocks in, the tree sort of wanted to do that. It was a way of manipulating.
I'm conscious these images are quite small and grainy, so maybe what we should do is move on to we've got a series of stills in an animation in a minute. I also wanted to quickly show this, which was the parametric stuff. So these are tension and compression colours of us kind of manipulating these at scale, building scale, and seeing where we might need to reinforce the structure or thicken up the beam and so on. So that's quite useful for informing the design.
2 minutes.
Perfect. I think this film is about 2 minutes long, just stills from the exhibition. So we'll just talk over the top. This is showing some of the radial cuttings, so the way the logs kind of splay apart. And there are various other images which we haven't had time to talk about. But,
the half round, that's those beams that aesthetically works well. The half round, we keep going back to any excuse to use it. Same with cleaving the quarters actually for the space frame. It's just such an easy and lovely thing to do. There's lots of people that are very keen from a lifestyle perspective to spend their days splitting wood. And part of this next phase and the element that I'm particularly interested in is somebody that wants to earn their living in this way. Can they afford to live in the countryside? And perhaps this is some elements that are telling us how affordable rural housing, in which direction that could go to increase skills and to improve the quality of life for those of us like living in the country.
And I suppose just a closing comment is it was a real pleasure to try and exhibit stuff in the kind of woodland that we sourced the material from, because I think particularly for students it made that connection to the way that the timber is grown, the way the tree is grown for the type of timber that you want. I think that's the link that sometimes missing in kind of design education, is an understanding of kind of silviculture and how to grow a tree to get the properties that you want. Crossing being another example of that. I'm aware we probably slightly rambled a bit there. If you're interested in the project, there's a QR code to take you to the website. If it's not too grainy, too far away, or just come and doorstep Nick or I.
Absolutely, and I think there's a Q&A at the mid-break.
Yeah. Thank you so much, George and Nick. That was terrific. I'm going to move